Hello, and welcome to this presentation, Getting Started with the LMG600 Single-Phase Measurements. This presentation provides a step-by-step guide to configuring, running, and interpreting single-phase power measurements using an LMG600 series precision power analyzer. This presentation assumes a very basic understanding of AC power and AC power measurements, including topics such as power factor and harmonics. If you're unfamiliar with these topics, or if you'd like a brief review, you may want to watch the presentations Understanding Power Factor and/or Understanding Current Harmonics before beginning this presentation. Let's start with a very brief instrument overview. The LMG600 series of precision power analyzers is available in both single-phase and multi-phase models, with different channel cards supporting different voltage, bandwidth, and accuracy ranges. The LMG has an intuitive graphical user interface and front panel controls, and it can be operated locally or remotely. The LMG also supports programmatic control and test automation. In this presentation, we'll walk through how to use the LMG600's graphical user interface and front panel controls to make single-phase power measurements. The front panel of the LMG has a large touchscreen that's used for both control and for displaying results. Two USB ports can be used to attach a keyboard and mouse or external storage devices. The soft menus on the right side of the touchscreen have corresponding physical keys. Tab keys, arrow keys, and the scroll wheel can also be used to navigate through the GUI and enter or update values. On the top right of the front panel, a set of measurement keys are used to access most measurement types, whereas the setup keys on the bottom right are primarily used for channel configuration and instrument settings. The rear panel contains channel cards for measurement of voltage and current. The processing signal interface card has a large number of inputs and outputs for interfacing with external devices or measurement sources. An external video display can be connected via the DVI interface, and both a LAN port and additional USB ports are provided as well. For single-phase power measurements, only a single measurement card is needed, since all card types support simultaneous measurement of both voltage and current. A single-phase connection between a source and a load requires a line or hot wire and a neutral wire. For current measurements, the neutral conductor is normally routed through the LMG measurement card. The voltage measurement connection is made across the line in neutral, as shown. Note that the 4mm or banana cables provided with the LMG are color-coded to match the sockets, making it easier to visually determine what's being carried on each wire. It's worth noting that for pluggable DUTs, that is, devices which are normally plugged directly into AC mains power, measurements are often made using a device called a breakout box, such as the LMG Mac 1 or similar. This box connects between the AC mains outlet and the device under test, and has 4mm or banana jacks for voltage and current measurement connections. This provides both easier and safer connections to the power analyzer. Channels on the LMG are assigned to groups, and for our single-phase measurements, we'll configure Group 1 to contain only Channel 1. We do this by pressing the Group Hard key on the front panel, clicking on the Grouping tab, and then clicking on any channel to bring up the Grouping Editor GUI, displayed here. The small triangle icons can then be used to move channels into different groups. In this example, we've configured Group 1 to only contain Channel 1. Note that the groups and their allocated channels are displayed as part of the status bar at the bottom of the display. Let's now start looking at measurements, beginning with the default measurement view. This view is accessed via the default hard key on the front panel. This view displays the most important power measurements, namely RMS voltage and RMS current, power and power factor, as well as apparent power and reactive power. These values are updated in real time, but the display can be paused by pressing the Freeze hard key. The default view can be toggled between few and many values by pressing the Values soft key. In addition to values from the default few view, the default many view also displays the AC and DC components of voltage and current, the AC frequency, and the measured impedance. Now let's look at more detailed voltage measurements, which can be viewed by pressing the voltage hard key. As before, we can toggle between displaying either few values or many values by pressing the Values soft key. In addition to the values we saw in the default view, we can also see maximum and minimum voltage values, and values for peak-to-peak voltage, rectified voltage, crest factor, and form factor. Current view is accessed via the current hard key, and also has views for few values as well as for many values. These measurements are similar to those we just saw for voltage, that is, basic values, as well as quantities such as peak-to-peak current, crest factor, etc. The many view also displays the peak inrush current since the beginning of the measurement. This value can be reset by pressing the Reset Inrush button. The Power hard key shows measured values for power, most of which are available from the default view. One set of values not available from the default view or from the few view are the values of resistance R and reactance X, used to derive the overall complex impedance Z. The last set of general measurement views is the energy view, which is accessed via the energy hard key. Energy shows the integration of power over a given duration, and the most important results are active, reactive, and apparent energy. The integration time of the measurement is also shown. This measurement can be manually started, stopped, and/or reset, and the LMG also supports starting measurements only when an external signal is received. Values can be either continuously reported, or they can be reported for a user-defined time interval. Note too that some additional measurement values can be shown by toggling the Few Many Values option, similar to what was done for other measurement types. Measured values can be graphed or plotted by pressing the Graph hard key and selecting a scope channel. This view shows values versus time, similar to the way an oscilloscope displays information. To enable a trace, simply press and hold one of the rectangles on the left side of the screen. A pop-up then appears, allowing the selection of group/phase, as well as the measured quantity, voltage, current, power, etc. This can be repeated for up to 8 traces total. Values can also be selected and plotted independently in the 2 independent scope channels. Here we see an example of voltage and current being plotted as traces 1 and 2. In order to scale the x or time axis, press the Time per Division soft key, or use the rotary knob. Note that this value affects all displayed traces. The y-axis values, here voltage and current, can be scaled using y per division and y offset, and each trace can be scaled independently by selecting the trace number. Clicking on the right or left edge of each hexagon will increase or decrease scale values in a stepwise manner, and this can also be done using the associated hard key as well. In addition, pressing and holding a hexagon will bring up an input dialog, where scale values can be entered numerically. The scope screen can be maximized by pressing More and then Display Maximized. If additional traces need to be added, or existing traces reconfigured, this must, however, be done in non-maximized mode. The Cursors feature in Graph View is enabled by long pressing the Cursors menu item. This activates the cursor configuration menus as shown here. There are 2 cursors, which can be placed on either the same or on different tracks. Both absolute and relative cursor values are displayed in a table. For example, here we've used cursors to measure the period during which the current waveform was non-zero. Another tab under the Graph menu is Harmonics, which requires a special license option. This tab can display voltage, current, and/or power harmonics, either individually or simultaneously. The zoom menu option is used to control the number of displayed harmonics. In this example, we're showing up to the 19th harmonic. It's also possible to toggle between displaying all harmonics or only odd-order harmonics. In addition, the display range can be set either manually or automatically with a linear or logarithmic scale. If more than one type of harmonic, for example voltage and current, are to be displayed at the same time, the results can be shown either as a single graph with side-by-side bars for each harmonic, or they can be split into separate graphs using the split menu item. This is not limited to only two traces. For example, voltage, current, and power harmonics could all be displayed simultaneously in the same ways. In addition to the graph view, harmonics can also be displayed numerically in table format. This is done by pressing either the voltage or current hard key, and then selecting Harmonics under Display. As with the graph view, it's possible to choose whether all harmonics or only odd-order harmonics are displayed. The amplitude results can be displayed either as absolute values or as relative values, that is, as a percentage relative to the level of the fundamental. Let's end with a brief summary. LMG600 series precision power analyzers can make measurements of both single and multi-phase power. For single-phase measurements, voltage is measured across the line and neutral conductors, and current is typically measured in line on the neutral conductor. Both of these measurements, voltage and current, only require a single measurement card. The LMG's touchscreen GUI and front panel controls are used for measurement configuration and for displaying results. A wide variety of both measurement and display formats is supported. In this presentation, we looked at both numeric measurement results, such as voltage, current, power, and energy, as well as graphical displays of both waveforms and harmonics. This concludes our presentation, getting started with the LMG600 single-phase measurements. If you'd like to learn more about power analysis, power measurements, or power analyzers from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.